Hello, my name is Soham Gandhi, and today's video is going to be on CubeSat interfaces. Before I begin, I'm going to go over some basic terminology that's going to be used throughout this lesson here today. Alright, now let's go over some general terms, starting off with the master. The master is the device that's in charge of all the operations and commands. It sends commands to the slave to tell it what's happening or to give commands on what to do. The slave receives the commands and executes them, and they can send back data to the master. However, they will not be sending back commands. That is usually not the role of the slave, but rather a master. There may be multiple masters and multiple slaves, depending on the interface used. The final term on this page is the bus. The bus is a conductor which allows multiple devices to share a common power supply, common ground, or common data line, basically allowing multiple devices to share a common signal. And this overall usually is used in I2C and buses similar to that. Now let's go through the basic signals that we're going to go through. So the main thing that we're going to see is high and low. All these signals and interfaces we're going to be using function on the basis of high and low. High is usually signified by a 1 or a logical high, normally a 3.3 volt or a 5 volt signal. A low, on the other hand, is usually equated to a 0 or a logical low, which is usually 0 volts to 1 volt normally. However, this changes depending on the interface being used. One way to go ahead and change what interface you're using and to change different modes and different levels of logical high and logical low is to use a level shifter, which is commonly used throughout these different interfaces between devices. Alright, so this is the last page of terminology, and we're going to go over the basic pins. The first kind of pin are the data pins. These are as simple as it sounds, just to transfer data. The next kind of pin is the clock pin, which is meant to send a signal, a clock, a regular interval time signal from the master normally to the slaves to go ahead and indicate between the devices a timing signal. This helps when it comes to minimizing errors and also maximizing the speed at which the data can be sent, because the devices can simply record the time and they know it's going to be the proper time since it's being used throughout all the devices. The last kind of pin is slave select or chip select. The main goal of this is to indicate which device is the master communicating to. The way it works is it sends a signal of high, logical high, or a 1, and once it's done sending, it's going to go ahead and bring that to logical low. This helps the slave figure out when it's going to receive the data, and in the end, helps to speed up the process too. Alright, now let's get into the fun stuff and the interfaces that are usually seen on CubeSats. There may be more interfaces out there, but these are the commonly ones that we've seen in our research and our actual CubeSat that we've been building. Feel free to go ahead and comment below if you see any other interfaces that you'd like us to cover, or anything else in general when it comes to these topics. We would love to go over it. Alright, let's start off with I2C, one of the most easy to use interfaces by far. It only uses 2 different wires to actually communicate, SDA and SCL, and allows you to talk to multiple devices and allows for multiple masters. And the way it works is it sends a 7-bit address to identify which device it wishes to talk to, and from there it sends the data or command. This actually works very efficiently and is quite fast. However, due to the fact that it has to send a 7-bit address each time and can only talk to one device at a time, it does sometimes slow down things depending on how many devices you want to communicate to and how fast you wish to communicate. The next interface is SPI. SPI utilizes 4 pins: clock, master out, slave in, slave out, and slave select or chip select. SPI is faster than I2C, but is more complex. The number of devices is simply limited by the number of slave select pins you have, and it only can have one master. The advantages with SPI is it's much faster than I2C, but the main disadvantage is the fact that there's more wires leading to more complexity. The way SPI functions is on the basis of whenever the master wants to send data to a slave, it's going to send it through master out, slave in. Whenever a slave wishes to send data back, it sends it through master in, slave out. This in the end is faster because it allows for transmissions between the devices at the same time. However, it also involves a lot more complexity when it comes to the fact that every time data needs to be sent out, the slave select pin needs to be set to high for the specific device the data is meant for. In the end, SPI is a great interface for faster communication than I2C, but does involve a bit more of a learning curve compared to I2C. Our next interface is UART. UART is one of the most commonly used interfaces out there today and is actually used in USBs today. UART uses two pins, RX and TX. RX of one device ties to the TX of the other device. Data is usually sent as one start bit, which is a low level, plus 8 bits plus 1 end bit of high level. This helps the devices figure out when the message starts and ends, minimizing errors in the end. Usually, when using UART, you're not going to be using 5 volts since it's regarded as very unreliable. And this is where level shifters come to play, because usually you need level shifters to help change between different voltages used by different specifications of UART, since UART does not specifically specify a certain voltage. Our final interface is not necessarily an interface, but rather a subsection of UART. RS-232 is a form of UART that specifies a certain voltage. RS-232 uses 12-volt logic to indicate 0 and 1, where 12 volt is equal to 0 and negative 12 volt is equal to 1. RS-232 is commonly used on satellites because it's much more reliable, and also due to the fact that since it's a much broader range in voltage, there's less possibilities of errors occurring. Please like and subscribe to this video and click the notification bell to let you know when new videos come out.